My name is Savannah Lennon, and this is Lab Report 3 for Physics 2211. This lab was focused on calculating the unknown mass of an object as well as the net force acting upon a star that has a unique trajectory according to our email. This is important for us to study because it displays the concept of the fundamental principle that is Newton's second law. This law states that for a constant mass, force is equal to mass times acceleration. If we rework this, we can derive the momentum principle, which is P final equals P initial plus net force times delta T. In the case we are observing, a star orbiting a black hole, the net force will be non-constant, meaning that it will not be equal to 0. This is due to the fact that the star is accelerating at each time step due to the curving nature of the trajectory. My initial conditions were all given, with g being the gravitational constant equal to 6.67 times 10 to the negative 11th, the mass of my star being 2.0 times 10 to the 30th, and the time step, delta t, being 1 day. In my code, I changed the day to be equal to 86,400 seconds because that's the SI equivalent of a day. Next, I used Newton's second law in order to calculate momentum by taking the initial and final velocities given by the code and multiplying each of these by the star's mass. After this, I was able to calculate the change in momentum and the change in velocity, and subsequently the net force. The net force is the change in momentum over the change in time multiplied by p hat, which is in the direction parallel to the motion of the star. I used the formulas that you can see on the screen, that the parallel component is equal to p hat times d magnitude p over dt, and the perpendicular component is the magnitude of p multiplied by dp hat dt, in order to calculate the parallel and perpendicular components of net force. These signify the change of curving motion, with dp dt perpendicular being the change in curving motion, and the change in speed with dp dt parallel. Now you see my calculations for the mass of the black hole. In order to calculate this, I took the net force acting on my star, multiplied it by the change in distance of the star squared, and divided that by the force of gravity acting upon the star. This is a simple derivation of the gravitational force formula, which is Fg equals g times big M little m over r squared times r hat, in order to solve for the mass of one of the two objects, which is the black hole. Also, you can see why I had to make the arrow scale so small, because if it were not as small as I made it, the arrows would take up the entire diagram and you'd not be able to see the black hole or the star in its trajectory. Here, you can see my star's trajectory after I've implemented all of the calculations into my code. All of these calculations resulted in me getting a black hole with a mass of 1.46 times 10 to the 34 kilograms and a net force acting on my star equal to 9.13 times 10 to the 28 newtons. You can see on this slide the forces that are acting on my star, as well as the outcomes of the calculations for my star and my black hole. Now, what does this all mean? This lab displays how acceleration, the rate of change in momentum, and net force contribute to the overall trajectory of our object, in this case, the star. It shows how the acceleration and its components, in addition to the net force acting on the object, both contribute to the trajectory of the star, meaning that the rate of change of momentum, dp dt, and the net force are equal based on Newton's second law. Now, what if our star took a different trajectory? How would that affect our results? In order to determine the exact results of this, I changed my email input in the code to be my personal email. And this yielded an overall net force that was equal to 9.7 times 10 to the 28 newtons, and a black hole with a mass of 1.69 times 10 to the 34 kilograms. Alternatively, what if we put a different black hole in the middle of our star's trajectory? How would this affect our results? According to the results above, being the ones that came from me changing my email, if we change the mass of the black hole, then the trajectory of the star should also change due to the altered net force, due to the force of gravity acting on the star by the black hole.